Don't hate on Jersey City.
All right, guys. Okay, we are ready to start.
That's Aaron, or that's Jagdip's background. That wasn't Jagdip's earlier.
You're right, David. So let's begin with our presentation. Yeah. Okay. All right. Can everyone see a black background and yellow wording?
Yeah.
Yep. All right. Okay, now
beautiful.
You can mute your thing and let's go through it. I tried to put together a presentation that had some background on what we are doing before we really get into analysis. The plan would be for me to set up the conceptual base. You can ask me any question by speaking in the middle. And then I'll turn over to David to talk about the data. He's been gracious enough to let us use a portion of his data. You should have a copy of the data with you. It's product and services, two different groups. We'll be doing multiple group analysis. And I'll turn over to Aaron, who will do the metric invariance, which you're quite familiar with. And then I'll take over in terms of scalar and mean, or even mean invariance. So let's dig into it and see what we're trying to do. Okay, so the first slide is talking about different kinds of differences we want to test for. So you can have hypotheses for different things, and I'm just going to go through each one of them. The first one is the hypothesis concerning mean differences. This is mostly common in ANOVA kind of design, in experiments. You want to know if the mean of a dependent variable is different for two treatment groups. So that's the typical hypothesis for mean effects. Slope effects is most common in regression, where you have two substantive variables, x and y. You want to know if the effect of x and y varies between groups, and you want to make a hypothesis about it. Corresponding to the slope, which is in regression, you are familiar with the latent slope effect, meaning I think most of you are doing a study in which there is hypothesis about latent slopes, which are simply the coefficients of path in SCN model. And essentially you're saying after accounting for measurement error and equivalence and common method and so on, relationships among substantive latent constructs fx and fy, they vary predictably across groups. That's what you are making hypotheses for. We don't do the last piece as often. It should be done, as I will explain in a minute how they can add insight, which is latent mean and slope effects, meaning not only I want to examine if the slopes are different in two groups, but also if the means of constructs are different in the two groups. So in some ways, we are combining the ANOVA design within a regression design. But the word latent is important. We are looking at means after accounting for measurement error, equivalence, common method, and whatever else we are controlling for. So these are more vigorous tests of mean and slopes. And AMOS allows us to do this quite easily, although the setting up is quite complicated. But that's the intention behind it. Why are we interested in means and slopes? Here is a figure to explain it. So this graph tells us how a latent slope difference will look like for two groups. The two groups, low and high, red and black shown here. The two variables are fx and fy. And we're simply testing if the slopes are different for the two groups or not. In this case, we want to know if 127 is different than 151. We do that in AMS by having these managed models, constraining the two to be equal, and then checking for chi-square difference to be significant or not. You're all familiar with this, but here there's another way of looking at some hypotheses. Again, Fx and Fy, again, two lines representing the two groups. But in this case, the slopes are not different. The number is 0.27. They may not be exact, but we're saying in the hypothesis testing it's not significant, so they can be estimated to be equal. But they are not the same. The means of Fy in this particular two-group example are not the same. So in the high group, the mean of Fy is less than the mean of the low group. And we would miss that latent mean difference if we did not estimate it and hypothesize it. So we tend to miss it. The third graph, which is the one we are going to be doing this afternoon, is both means and slopes. So in this example, we have again Fx and Fy, again two lines representing the two groups. In this case, the means are different. The high group has a lower mean than the low group, but also the slopes are different. The high group has a more positive slope, whereas the low group has a less positive slope. And these can be all tested statistically to be significant using the managed models idea within it. This is basically the theory behind what we're going to be doing. Just want to see if any questions that I can answer at this point.
I'm good.
I'm assuming all are good, so I'm going to proceed ahead unless somebody stops me. The next piece I'm going to look at is some ideas going back to 1988. There's a nice paper written by Anderson and Durbin. It caused a lot of stir at that time. These authors were chastised for proposing a two-step method. It took almost 10 years for that two-step method to be reinstated as a good idea. And basically what they were saying was that don't do your SCM with the measurement and structural together in the first go, but do them in two steps. Step one, make sure your measurement model is adequate, and that meant test the measurement model, allow the living variables to correlate, adjust it so that you have good fit. If the model of this, if the fit is not good, don't test for structural models. And in this case, I want to point out, I really mean the measurement model without the error covariance. Because I said before that every time you allow that, you weaken your measurement model. And the fact that the measurement model is necessary but not sufficient condition for the fit of the structural model, which really means that these two are quite different things and should not be mixed up. Measurement models should not be mixed up with structural models, but they need to be estimated in the last step as one big model to allow for this maximum likelihood estimation with full information. But to do that in the first instance can be problematic. We have an example of this, a very good example of this, in the Neck and Meyer paper you are working with and revising. If you remember in that paper, they found invariance in the structural model. But when you do your own analysis, you'll find, and I know some of you did find it, but there's a reason you didn't, and we will have an analysis of that as well. When you really do it the right way, there are paths which are quite different. And the reason they didn't find it is because the degrees of freedom that come from the measurement model are so huge that they don't allow any differences in the structural model to be detected. So for example, if you had 488 degrees of freedom and 400 came from the measurement model, 88 from the structural model, and that would happen if you had a lot of items and the measurement model was quite complex, then of course any misfit at the structural model would be overpowered by good fit at the measurement model. So they would compensate each other and you would not pick it up. And that's another reason to then separate. All right, let me move ahead now. And this is a summary of the two separate theories idea. I discussed that in the last residency. Not only are measurement model and structural model different things, they are about different theories. So measurement theory is about mechanisms that produce responses to survey items. They have to do with how the items are constructed. They have to do with the scale you are developing, which is unperturbed by samples, context, and time. That's why invariance of the measurement model is so crucial. You're basically saying the scale can differentiate reliably and validly samples from different countries, from different groups, from different organizations. And as you can tell, without that, you cannot test your hypotheses. Different theory. Structural theory is about relationships among the living constructs. That's typically what you mean by theory in the program. We don't do much of the measurement theory, but actually there's a whole body of work on this theory. And in structural theory, you're interested in whether the relationships differ for different samples, context, and time. This tells us how different groups behave. And the key point here is you cannot do the structural model analysis of differences unless you can prove that your measurement model is invariant, meaning that you have to show that the mechanisms are unperturbed by variability in samples, context, and time for the measurement model to find differences for samples, context, and times for the structural model. Are we good? Move ahead.
So Jagdip, it's Lori. So
yeah.
we can't really do, within our own studies, we can maybe split our sample size into two pieces, but we can't change context or time, probably, right?
You're right. I think many of the studies are not designed to do multiple group analysis, or they could have been in design, I think. But what I said in the class is that when you are reporting your results, you're basically saying that you take my data and you can split it any way you want, and you should get the exact similar coefficient as I'm reporting. So it's not a bad idea that even if you had not planned it, to do a supplemental analysis where you take any of the background variable of the organization or the individual, and you break your data into two groups and just work through to make sure that your coefficients, which means structural coefficients, do not change dramatically for the two groups you created. Because you can tell if they did vary a lot, significantly that is, then the coefficients you are reporting, which are averages across groups, are not that useful for interpretation.
Thank you.
Yeah, welcome.
But Jagdip, can't we, I know that we can break our data into different samples. And I agree with Lori that we can't break it into different times. But I think we can break it into different contexts, can't we?
Absolutely. You don't have to do all three. I mean, you can do by samples, by context. I think most of you don't have longitudinal data, so you can't do it by time. But if you did, that would be a way to do it. So take anything, any one of these areas, and just go through to make sure that your results are unperturbed by the groups that you create. All right, so let me proceed. I assume everyone is good with that. So the key article you need to keep in mind is this article published in 2004. There's many others now that go into more detail. But this is a good, sound discussion of this approach. It's by Ploy-Hart and Oswald. I think I'll ask Aaron to have a copy available for you if you want to dig into it. As in all articles which are of this type, they lay out the entire set of procedures that you must follow in order to work through it. But really, in implementation, there are many tacit kinds of things which they don't tell you. And when I go through it today, you must keep an eye on those because they're small little things that can throw you off and burn a lot of time. So just pay attention to what I'm going to be indicating as supplemental information as you read the article. The approach is called MAX, which stands for Mean and Covariance Analysis, I think, because it's doing both means and covariance among variables. And I'm going to, it says there, it's based on the idea of several nested models. We have done that. We've done these models which are nested using the managed models. So you're familiar with that. You can add the common method factor in each group if you wanted to. It gets complicated. And the last one is instrumental variables. And this you probably haven't done, but in most survey research, there is a lot of concern about all kinds of biases, social desirability, and so on. And if you have included a variable of social desirability, then you can also include that variable within this design so that you can remove its effect. It is possible to do that. Okay, the different models we have to estimate. There are 7 of them, although the article has additional ones, but I don't think you really need them. These 7 are critical. I think you're quite familiar with the first 2, configural and metric. And configural, you know, is about the item loading pattern. Metric is about item loadings, meaning the exact loading are equal or not. And then we have scalar, which is the item intercepts. I spoke about that not sufficiently. There's residual invariance, which is for the item error variances. We haven't done that. Factor variance and variance, which are really factor variances. We have not done that either. And the last 2 are corresponding to latent means and slopes. So factor mean invariance is about latent mean, and factor coefficient invariance is about latent slopes. We are most interested in 6 and 7, but we can't get there till we go through the entire set of procedures. But if you ask me, which of these are the critical ones, and here there's a slide I think you really need to pay attention to in order to work through this. You definitely need metric invariance to proceed, but a partial invariance is absolutely fine, which means for the majority of your items, but not all of your items, you meet the property of metric invariance. Scalar invariance is absolutely essential, but again, not all items have to pass that. A partial is okay, and the partial we mean majority of items. And the idea there is that as long as the construct can be identified by a majority of items, the remaining items can be variant, both metric and scalar. The trick here to remember is that for any one given item, if it does not meet the metric invariance property, it should also be released from testing for scalar invariance, which means for each item, metric and scalar is like a pair. The item must meet both the properties in order for us to be able to use it. Is that point clear? I just want to make sure we are not missing that piece. I don't hear a sound. Everyone's speaking? Okay.
I think it's fine.
Okay, good.
Yeah. So, Jagdip, what I heard you say was, it's Lori again, was that although you'd like to have every item load the same and every intercept be the same, that if you get the majority of them to do that across your groups, that's good enough.
That is good enough. Yeah, you will rarely get all of them. It's not going to happen. So majority is sufficient. So the last thing I said was it's like a pair for each item. That is, for a majority of items, both metric and scalar should be fulfilled. It can't be that for some item you have metric and for other items you have scalar. It's for the same set of items. You should have both properties fulfilled.
Oh, okay.
Yeah,
Yeah, thank you.
Below that, you see some crossouts, residual and factor variance and variance. These are not necessary conditions for us to get to where we want to go. We are not in the business of testing for invariance to the last dot, as psychometricians would want to do. Instead, our goal is to check for latent mean and latent slopes, which are the two red things at the last 2 points. And for us to get there, we need metric and scalar, but we don't need residual really. And we don't need factor variance. The factor variance is good to have, but it's not necessary. We can estimate it to be different. But the two things we're interested in are the factor mean invariance and factor coefficient invariance. That is our structural hypothesis testing. They relate back to the graphs I showed you in the beginning about slopes and means. And to get there, all you need to pass is 1, 2, and 3. I show a red line to them only to mean that our hypothesis most of the times is that we would not find invariance here, that the groups would be different. So we want to reject that hypothesis of invariance to then understand why the two groups are different. Whereas for the measurement part, 1, 2, 3, you want to accept the invariance. And just to complete, if you don't clear up 1, 2, and 3, you cannot do 6 and 7. Any questions at this point?
None for me.
Jagdip, it's Adrian. Why is 6 and 7 crossed out? Because, you know, like a half an hour from after our class, and I go back to my notes and I see 6 and 7 crossed out, it appears that you're saying that it's we don't need it, but I thought you said that it is needed. I'm a bit confused.
Yeah. So the red color means that is our focus. We want to get to 6 and 7. The double stripe through means our hypothesis normally is about rejection of invariance, meaning the two groups would be different means and they will have different slopes. So males are different than females. That's the kind of conclusion we want to draw. So the double stripe through is about our expectation of rejecting that, whereas 1, 2, and 3, our expectation is to accept the invariance.
I think this is Solange. Adrian, I think what Jagdip is trying to say is that by the time we get to 6 and 7, we actually want to show that there is a difference between the groups. Otherwise, why bother doing the work? That the only way to say that they're different with meaning is to make sure that the difference doesn't happen at the measurement level.
That's right.
That the difference actually happens in the behavior level.
That's right.
And so that's why we have to say that the metric and scalar measures that we use are invariant. But what we want it to lead to is that there are differences between the groups, but those differences are explained behaviorally and not through our measurement.
That's right.
Yeah, so to me, 6 and 7 is more of an analytic concept, whereas 1, 2, and 3 are more
Mechanical.
Yeah, correct.
Okay, thank you.
Yeah, I hope one day you would also think of 1 and 2, 3 as analytical and conceptual, just as 6 and 7 are, but they're totally different things. But for the moment, that's not. Okay, so let's now go to, I'm just going to, this is the most important slide. you'll be surprised how often we will miss this as I go through the steps. But just keep an eye on what I'm going to say here. Before you do the multiple group, I think the initial checks, most of you should be familiar with this. That is, it is always a good idea to run separate analysis in each group before you do multiple groups, so that you can ensure that the hypothesized model fits the individual group data well. So before you go to multiple group, again, do the individual groups, make sure the measurement model is working out right. Now, always run EFA to cross-check, and I think I mentioned that to Joe as well in Joe's presentation, that when you have, and Nicholas as well, I think, even though your CFA looks great, and I hope there also we should not just focus on model fit. The coefficients and t-values are very, very important. They must be large and significant. But even a more significant idea is once the CFA looks good, go back and run an EFA just to make sure there is no cross-loadings which are not detected and picked up in CFA. And remember the rule, if the degrees of freedom are large, small places of misfit will be overshadowed by the overall good fit of the model. So it's good to check EFA. You will pay a price down the road if that is not good. So it's a good idea to do that. The last bullet there is in these complex analysis, it always helps to have good starting values, but it's not relevant for AMOS because AMOS doesn't allow you to put in starting values. So you can ignore that. But for other software, it is possible. Let's go to identification. There are, when you do multiple group analysis with means and slopes, there are two ways of identifying each construct in your model. And you use any one of the two. You don't use both, you use one of the two. The first one is called the reference group method. And we call this reference group meaning that one of the groups is going to be a reference group for us, a baseline group which we will use for comparison. So if you're doing males and females, you have to decide which group is your reference group. Let's say that's male. And you're going to then look at the female group with respect to this reference, male. Why do we have to do a reference group? Because when we're doing a latent variable hypothesis testing, we don't have a real variable to work with. Everything is relative to something. And for that reason, a reference group has to be identified, which will become the point of reference for all other groups in your comparison. If you had 5 groups, you'd have to choose any one of them as a reference group, and the remaining groups can be compared with respect to that reference. We'll be doing a 2-group analysis today, and I will be choosing one of the groups as a reference group. And for the reference group, the latent variance is set to 1. This you know from what you normally do in a CFA. But the latent mean also should be set to 0 or fixed to 0 for the reference group. And what that means is that the reference group will have a mean of 0, and then all other means will be estimated with respect to this reference group. So that's one way of identifying. The second way is called the marker variable method, which means you fix the loading of any one item for that construct to 1 or to any other value. So it doesn't have to be always 1. You can choose a value that you prefer, but it has to be fixed to that value. And its intercept also has to be fixed to a value 0 or any other value you like in one of the groups. So you take one group, take one item for each construct, you fix its loading and its intercept to some values. In this case, the example shows 1 and 0, but they don't have to be 1 and 0. They can be any values needed to identify a latent construct. You have done this in your analysis for every dependent variable, because for dependent variables, you cannot set the variance of the latent factor. That method is called the marker variable method. And what I said here is you choose one of the two, which means you can't do both. We will begin with the one I circled. That will be the more common way we will be using it. But we'll be shifting between the two because the analysis will require us to do that. So we have to be fully adaptable to move between the two choices as the analysis will demand. But at any one given time, we'll only use one. Now I want to stop here to make sure everyone gets the idea.
Keep going.
All right.
I think it might make more sense when we see it.
Excuse me?
I think it might make more sense when we see it.
All right, sounds good. Let me go to the metric constraints. When we're doing the metric equivalence, we don't need to include intercepts, only the means in this step. We should only do it for scalar. And factor loading is what the focus would be. You'll be fixing the latent variances to 1 in both groups. You're all familiar with it, so let's dig into it. But in the scalar constraints, when we do scalar analysis, we'll be using means and intercepts, and we'll be using different methods for identification, as I mentioned to you. And the last bullet won't make sense to you now, but when you get into it, you will see how you need to worry about it. I'm going to skip this step about residual constraints. This is the residual error variances. You will follow the same plan as for the scalar, but since it's not critical for our analysis today, I'm going to skip that. And this I will talk about as we go through the steps. I'm going to turn over to David so that he can talk about the data.
Okay, this survey had 49 questions, and I can elaborate a little bit more on those if you like. But for now, we'll say it was a very quick survey. When we did the pilot pre-test, most of the executives that we tested took less than 7 minutes to do it. So it was a very fast survey. We received 343 responses, and we sent out a significant amount of emails. Breakdown of the questions, of which most of these are the IVs except environmental behavior and safety behaviors were the DVs. The mediators were mindfulness, learning orientation, and absorptive capacity. So any questions on that? Out of the constructs that we've selected for this example, we had mindfulness, which had 4 items. Absorptive capacity had 6, and the safety had 3. And Jagdip, I think after watching Aaron's video, it may be interesting to go back and visit question 49 and why it came up to be non-invariant. We had 183 responses for companies who worked for what we call manufacturing companies. They make things, capital goods. And about 147 were companies that we provided, or as we called service providers, financial industry or the IT industry. Okay. Anything else?
Thank you, David. Let's move on to the next step. I think I'm going to turn over to, so now what we're going to do is go to the actual Amos runs and the way we set it up from measurement, from metric to scalar. So I'm going to turn over to Adam, who would go through the metric in there.
I can see a cursor moving back here. Am I the only one?
I don't hear anything.
Say that again, Lori.
Oh, good. So it's not just me. I can't hear anything.
Yeah, I have no.
Right. How about now? Can you hear me?
Oh, Aaron, there you are.
Yes,
Yes.
there you are, Aaron.
Okay. Good.
You were
Good.
busy with your cursor, but we couldn't hear you.
All right. So just to reiterate, this is the measurement model that David has been working with. It has the safety, mindfulness, and absorptive construct, and a number of items that are loading on each. And what I'm going to walk you through here conceptually is how to test for metric invariance, and that's invariance in the factor loadings. And I sent out a video on how this is done, so you can look at that one afterwards as well, but I'll also go through it here, both on a conceptual level as well as looking at AMIS. All right, let's see here. Yes, so in order to test for metric invariance, which is invariance in the factor loadings, first we do a full test of invariance for all the factor loadings at the same time. So we're basically comparing an unconstrained model to a model where all the factor loadings are constrained simultaneously to be equal across groups. And if this shows invariance, then we're basically done. On the other hand, most of the time, this is not going to show invariance, and we'll have to go into and see for each construct if we can find any invariance or any source of variance in any of these constructs. And if we can identify variance constructs, then we can delve even further in and look at each factor loading individually for invariance. So let's have a look quickly in AMIS to see how this is done. So I have my model here. Let me see here. This is the model that we're going to use. So I've set up the model. And here, you don't need to have means and intercepts because we're not testing that so far. So the model is set up with two groups. And the variances here are constrained to 1, as we're used to. And you can see that for all the factor loadings, as I shift between the groups, you can see how they have been labeled with different labels for the two groups. So what we're looking at now is literally unconstrained model where everything's free to vary. I've set up a number of models here, and the way I've set them up is through clicking the multiple groups analysis and specifying the constraints that I want. And then you can also subsequently edit the constraints in the Manage Models box. I'm going to show you how to do that. So the first model that we're going to test is full measurement invariance. So this looks like this. Here you have all the factor loadings constrained to be equal across the two groups. So A1-1, this factor loading here, equal to A1-2, which is the same factor loading, but in the other group. So let's first test that model and see what we get. And here's the text output. You click model comparison and assuming model unconstrained to be correct. We're just going to look at this first row here. And here we can see that this is a p-value that's below 0.05. And that means that there are significant differences in fit between the model which has full metric invariance and the model which is unconstrained. And therefore, we can't at this point claim that we have metric invariance for the model as a whole. So what we want to do next is that we want to go in and constrain and look at the constructs one at a time. So I built a number of other models here, one for mindfulness, one for safety, and one for absorptive. So let's have a look at those. First, the model for safety. This is a model where we only constrain these three factor loadings. So that allows us to test whether there's invariance only in this construct. And we let everything else vary. And I've done the same for absorptive. So here we have all of these items. And for mindfulness. So, and actually I've already run these models, so we can just go back to the outputs. But if you haven't put the models in at this point, you need to rerun your model through pressing calculate estimate, and then we go to the text output again. So now we can look at these lines one at a time. You can see here for the mindfulness construct, we can see that we have a p-value of 0.66. And that means that they're not significantly different from each other. The model which is fully unconstrained and the model where we've only constrained the factor loadings for mindfulness. So mindfulness, we don't really need to worry about. If we look about invariance for absorptive, we can see again here that this is also not significantly different from the unconstrained model. So we have a good case for metric invariance for absorptive and mindfulness. Now, however, when we look at invariance for safety, we can see here that when we constrain all the factor loadings for safety, this yields a model that's significantly different from a model that is completely unconstrained. So it seems that the safety construct is the source of our metric variance here. However, we would like to locate the source of the variance on an item level, because it could be the case that there's only some of these items that are showing variance, whereas others are actually invariant. And this has consequences for our scalar invariance analysis. Remember how Jagdip told us that we need these to be paired up, metric invariance and scalar invariance for each item. So it's important for us to understand not only that it's the safety construct that's problematic and variant here, but which of the particular items. So I created further new models, and it's one for each of these items. So these are basically models where all the items in the model have been constrained except for that particular one. So if we look at Q46, for example, you can how does this make sense? Does this make sense? 48. Okay, so here we actually have 46. So there's been a mistake here. So here you can see how everything's constrained except for A11 and A12. If you look at Q49, and that's 48. So there's been, and Q46 here. Yes, this is where A32 is missing. So this is Q49. I'm sorry there. There's just some small mistakes. So now these should be correct. So we can close this and we can test these.
So Aaron, it's Lori. Before you were constraining each line for the ones that you were testing. Now you're not constraining them?
So when we constrain one item at a time, what we're getting is to check whether that item on its own is invariant. When we're constraining all items except for one, that is a test of whether everything else is invariant except for that item.
Gotcha. Thank you.
So if we run this and go back to our output, we can see here that if you look at the model here for Q46, we can see that a model where everything else besides Q46 has been constrained, it's on the verge of being invariant, because the p-value is still below 0.05, but it's still fairly high. So in a way, you could argue that this model is significantly different from the unconstrained model where Q46 is free. If you look at invariance for safety, you'll see that even when we constrain everything except for Q48, this is still significantly different. and a model where everything except for Q49 is constrained is still is not significantly different from an unconstrained model. So in this particular case, what we can say is basically that for Q46 and Q48, these are borderline items, and it might come back to haunt us later. But the biggest source of problem here is Q49, because it doesn't seem like metric invariance holds for this particular item. So that's going to have consequences when we move on to test for scalar invariance.
Can you bring up those results one more time, Aaron?
So here I'm going to move the control back to Jagdip, and he's going to clarify a couple of points.
Can you go back to that? We had the numbers, so we can look at that.
Thanks,
Dave. You're welcome.
While we are just working through this, any questions on the metric invariance?
This Adrian. That whole safety construct, I mean, you know, you can kind of say there's Q48 is the worst of them, but they're all pretty bad.
Correct. The safety, I think what you see as looking on forward is how the safety construct behaves as it's been. But you're right, safety is the most common.
Jagdip, it's hard to hear you now.
Yeah, we can't hear you.
Is it hard to hear me?
Yes, we can't hear you.
So let me get the control back. Maybe that one.
Well, I think you have to request it because I don't know who you are. Go back up here, turn. Then you should be able to press the participant up here in the menu. And code. Oh. This is 3, 2, 1, 1. 3, 2, 1, 1.
Okay, I think we are getting this. Can you hear me now?
Oh, yeah.
Good. All right. So
Much better.
Are there any questions for Aaron and I on the metric invariance before we get back into the other next pieces?
Aaron, the item you picked as being the problem one, this is Lori, the item you picked as being the problem one, that was the one with the 0.024 p-value?
That's right.
Thank you.
That's right.
Could you go back to the slide that showed the loadings and the significance, or no?
How can we go back? I'm on a different place. This one happened. This one happened.
David, it's in the video.
Since we're taking control from Aaron back to me, I can't get that output. But can you ask the question so we can answer it?
That's okay. I think that's fine.
David, it's in his video. If you watch his video, he walks through that entire thing that he just did.
Yeah, I did find it. So what I'm going to do is, now this is a good time. If you guys want a break of a few minutes and stretch out, this is a good time to do it, because once we get going, we'd have to finish what you see on the screen at the moment, which is a sequence of 4 steps. And I've laid it out in a systematic fashion so you can see it and apply it to your own work. So tell me, you guys want a break at this time, or are you good to go?
I'd just soon finish.
Yeah. But I don't see anything on my screen. Am I on the wrong screen?
No, there's nothing on the screen.
Okay, good.
Oh, there's nothing on the screen?
No. No. We're back to the blank screen. I mean, the one with the headset and the little people.
Oh, I see. Yeah, got it. Sorry, I'll do it.
Yeah, let's keep going.
So wait here. I can't do it.
Always move it. Hold
Back to
you.
Just hold on. I think we are trying to get this post roll back to me. Yeah, I got it now.
While we're waiting, I got a question. Which mindfulness scale did you use?
All right. Can you see the screen now?
Yes.
Excellent. All right. So, yeah.
There was a question about mindfulness, and I thought I'd answer that quickly.
Sure. Go ahead.
There was a collective mindfulness article written by Wiki, the 2001, Managing the Unexpected, Assuring High Performance in an Age of Complexity. So I can send you the article if you like. They were pretty well defined in that article.
Yeah, no, I know why it worked. My question then is, why did you use collective mindfulness and not individual mindfulness?
Well, we are specifically looking for the company's responses, not individuals, even though the individuals are the ones responding.
Okay.
All right. Any other questions before we begin? Okay.
Jagdip, this slide is not part of the slide deck that we were sent out. Are you going to send it to us when we get a chance?
It should be.
Well, you should be able to download it from the WebEx.
Yeah, that like is a whole mystery to how that works. You could send it out as an email.
Yeah, Aaron's right. That's not part of the slide deck that was sent out.
Okay, we're going to see what we can do. Just hold on. So
You can't access the.
No. I want you to tell them how to get it.
Oh, so you can't access the files that we uploaded to the WebEx?
I'm not seeing that option.
Aaron, you sent about 6 or 7 emails, so it'll take us 5 or 10 minutes to go through each email to figure out what's going on.
How do you want this to be sent?
Just send it to an email to us, the class, DM213.
Yeah, sure.
Yeah, just the whole deck.
Yeah. So Aaron is going to send an email with that attachment. And I do think it would be helpful if we had this part of the presentation open as we work through it. So just give us a second.
David, this is Adrian, while we were working.
Yeah.
Yeah, go ahead.
Yeah, Philip was asking about the unit of analysis, and I was going to ask you the same question because, as far as I know, absorptive capacity, not the construct Philip asked about, but that is only at the organizational level. So that makes sense what you were saying.
Yeah, we wrestled back and forth, Callie and I and James, and what we're trying to do is attract the top 10 or 20 executives of each company, hoping that they represent the organization. So that's the reason why.
All right, I think the email has gone out, so make sure we can open it and get to this slide.
I got it.
Good. Very good. I'm going to focus on the leftmost box. That's what I'm going to do. And the way I've structured this is to say, what should we be doing for the loading? By loading, I mean item loading. Intercept, I mean item intercept. Latent mean, that's for the factor. And latent variance. So C would say,
can you get closer to the mic? I can hardly hear you.
Construct to invariant value in both groups. What that means is that we just finished the metric invariant. So the loading which is invariant, take any one for each factor, you must fix the loading for that item to the value you obtained during metric invariant. The intercept for that item, for the same item, should be constrained to be equal in the two groups. The latent mean to be fixed to 0 in the reference group, and latent variance to be fixed to unity, 1, in the reference group only. So this is our identification at the bottom, and the top ones are to help us get the intercept estimate. Now, notice how I do this in the Amos program. On this side, again, stop me anytime. There are two groups, producers and service providers. Let me first look at the construct, the three of them. You can see that for producers, which is the group here, the mean, so if I click on this, the parameters, the safety has a mean of 0 and a variance of 1. Similarly, mindfulness has a mean of 0, variance of 1. Absorptive, the same, mean of 0, variance of 1. And our idea was that we will do this only in one of the groups, not in both groups. So for service providers, second group, notice the mean is left blank, which means to be estimated. The variance is also to be estimated, given a name, a ad score. Similarly, for each one of them, we have a name given to the variance. The mean is left blank. It has to be estimated, but left blank. And the variance is given a label. You understand why the label is given for variance, because we're going to test later on if the variances are equal or not. Does that make sense?
I could tell you all that is new to me.
Yeah, I know. I think, David, you find almost all of the presentations from now on to be new. This is something which I did.
Jagdip, your audio quality is not very good. It makes it hard to understand what you're saying.
If you can plug into the headphone jack.
So where is it? Let's pick it up here.
On the
Oh,
Yeah, if you guys are on a speakerphone, we can't hear you very well.
can you hear me now?
Yeah, you're echoey a little bit.
Yeah. Lower your volume. That's good. How about
Hello,
now?
hello, hello.
Can you hear me now?
Yes,
Is it clearer?
yes.
Excellent. All right. So I wanted to make sure first that, do you want me to go through this process again, or are you clear about what I did about the individual latent construct?
Is Aaron going to make a video of this?
He is.
Okay, thank you.
Yeah, I think a video would be an excellent way to digest it.
All right. Are you guys having digestion problems?
Yes.
We're having attention deficit disorder. 2.5 hours.
Let me understand. Disorder, digestive problems, headaches. What else is going on? So would you rather that we do it as a residency? Would that help more?
Yes.
Well, I think it helps to have a video so that we can study it at our leisure and look at it again and again. It's helpful for you to watch and listen to this, but without having a video in the background so that we can go back to it, it's very hard to remember something new.
Yeah.
10 minutes after we finish with the video.
So,
I couldn't agree more.
And then, if we could do it ourselves first, we could come to the residency with questions, or where it wasn't clear.
So what I'm hearing is the following, and I want to make sure everyone is on board with this. What you're saying is the digestion problems require us to stop at this time. We create the videos for these materials, which you can review at your leisure, and that you work through the data and the famous files given to you before the next residency, so that we can quickly cover it and go through questions you might have, other issues that may come up while you implemented it, because actually it's going to get very complicated very soon, and if that's not going to be the most effective way, then I think we should go through this plan that I just laid out. Is that correct, my understanding?
Yeah, that's correct. I agree with what Adrian said. This is Donna. What is priceless is being able to pause these videos, and we would all be pausing the videos in different places. And so it becomes more of a personal learning experience to go through the videos and observe them and ask our own questions and then figure them out.
Good. Good. All right. Is there anyone in opposition to the plan?
Well, the only other comment I'd make, Adrian, is that in addition to what everyone has said, I actually think it would be helpful for you to go through this one time.
I'd be willing to watch.
Well, if most of you are willing to watch only, I will get the digestion problem.
It's a good thing you have a sense of humor, Jagdip.
So, besides Adrian, anyone else who has the burning desire to go to?
I want to see this. Well, why don't we divide it in two groups? For those who do not want to stay in the call, they can leave, and then the ones that want to watch it, we can watch it.
Sure. That'll give me less digestion. Is that everyone okay with that? That people can disconnect? Those who would prefer to not hear my voice anymore and enjoy the evening, and those who want to stay back, you can.
Well, you know, Jagdip, I didn't really have anything else planned for this evening, so I don't mind sitting here and listening and watching.
All right. So that's Joe, I understand. So Joe, Adrian, and Millie. Are we losing all others?
No, I'm staying. It's Donna. I'm staying.
This is Deirdre. I'm gonna stay too.
Yeah,
I think
the problem, Jagdip, is that we can watch, but I don't think if you asked me to play along with you, I'd be able to do that.
Yeah, I think I understand fully. I think for many of you or some of you, it may be better to just do the videos because it's going to get so complicated in a while you're going to say, oh, this is just too much.
Yeah.
And I will not be offended. Like I said, if you were just willing to watch, that will give me a digestion problem. So don't feel, I don't think you lose anything by going to videos. I think Aaron does a very good job in putting them together. And then you can recreate them. You have all the transcripts.
Yeah, I think Aaron's videos are excellent.
Yeah.
All right. Well, I'm going to lower your indigestion problem and drop off the call there, Jagdip, because all I can do is watch at this point. So thank you for a lovely afternoon. Everyone have a great weekend.
Okay. Bye, Laura.
Bye.
Bye.
Bye-bye. All right. So can we get a good sense of who's around?
Hi, Jagdip. This is Joe. I'm still here.
All right.
Haley's here.
Deirdre's here.
I'm here for now.
Oh, David. What does for now mean?
Can you hear me? This is Eric.
I do hear you.
Okay. I'm here for a little while longer before I die.
All right. Oh, don't die on my seminar, please.
No.
Sherry's still here.
And Dave is still here.
David,
I thought this was Dave's here. I thought this was a 3-beer seminar anyway, so I'm just going to have one more.
Yeah, I was going to ask Jagdip, can we start on our wine while we're doing this?
Well, you know, you can't because I can't get mine.
Yeah. Dave, 3 beers, you're way behind me. You have to catch up, buddy.
Man, so why didn't
Dave, you're in the background there. You know, I've already had my 3rd scotch.
All right, I'm catching up.
I'm on my 2nd beer. I don't know what you guys are doing.
Wow. You know, I think I should have come prepared for a group like you. All right. Now that you've talked about wine and beer, I am motivated to finish it at speed so that I can have my wine with my life, which I do enjoy. So, maybe you can start it?
Yeah, go quickly.
Go quickly. All right. Let's proceed then. I'm going to close this for a while. Okay, so to go through this, you need this thing in front of you. I assume you understand how I put this together, the first box. It tells you what to do in the first step of the scalar invariance. And I just showed you for the latent mean, I fixed it to 0 in the reference group only. And the variance was set to unity 1 in the reference group only, and it was left to be estimated in the other group. I'm going to show you now about the loading and the intercept for one of the items for each construct. I'm going to set it to a value that we obtained in the metric invariance run, and I'm going to constrain its intercept to the equal across groups. So watch this now. This is our run. For safety, I picked this item. You see its value is 0.569. How did I get it? This is the actual value of the coefficient estimated in the metric invariance run. Similarly, 0.683 here for mindfulness is the actual value in the metric invariance run. And finally, for absorptive, 0.626 is the value from that metric invariance run. I said that I'm going to set the intercept for the same item, for the same pair, to the equal. And here is the intercept I61. That's the intercept for this item. And if I change the group to service providers or to producers, the value is exactly the same, I61. So, and you can see all groups are checked here, so the same value is being estimated. That's true not only for this, it's true for this one as well, I21. You can see all groups are checked, the same intercept. And finally, for I12, all groups checked. For all the remaining items, the intercepts are free to be estimated. Good example is here. Q46, all groups is not checked. Q49, not checked. 14, not checked, and so on throughout the entire analysis.
I gave questions. The factor loadings come from the, I don't know, you call it a control group and the non-control group. Which one did it come from?
See, because they're set to be equal in the metric invariance, they have to be the same value.
Okay, got it.
Got it? So we have to choose that item which met the property of metric invariance. We can't choose any other. So we did not choose Q39 here because it did not meet the property, but we can choose any of the other items. You will also notice the loadings, the items which had met the invariance property are set to be equal. So you remember in mindfulness, each of the items was invariant. So we can see here for this first Q14, the loading is A42 in one of the groups, and it's the same in the second group, A42. So the same value in both the groups, so that the loading is set to be equal as you found in the metric invariance line. That will be true for this one. The loading for Q16, same reason, it should be identical in the two. And in this case, all groups are not checked, but the value here is exactly the same, A62, either if I do producers or I do service providers. And that will be true for all of these loadings, which are found to be invariant in the initial time. So you fix one value to a given value, set its intercept to be equal, all other intercepts are free. The loadings are constrained to be equal as you found in the metric index. Are we good?
Yep.
All right. And you'll see a bunch of these managed models. I use them very freely, so I keep adding. I deleted some so that we won't have too much complication. But what do I want to test here? Our main test is whether the intercepts for the items are identical in the two groups or not. I cannot do any testing unless I show that. So my first managed model is naturally the all intercepts constrained analysis, and it has all the intercepts from the two groups to be set to equal, so I can test if they are equal or not. And if they're not going to be equal, I want to do it by individual constructs. So I have one for safety intercepts, the two of them, because one of them has been set to be equal, so I can only use two, one less. Similarly, for mindfulness, I have three of them. There were 4 items. One has been set to equal, so I'm checking the remaining 3. And finally, the absorptive capacity. We have 6 items, so I should have 5 of them. And you can see 5 here. We check if the intercepts are equal or not. And with that, I can run this analysis and see what I find. That's my run. You want to always check the notes on the model to make sure there are no strange findings. There seem to be none. You want to check in model fits if the model has good fits to begin with. And usually you can go to RMSCA. You can see most of them are non-significant. They're borderline, but they're not significant. So we are fine. And finally, we want to go to model comparison to see the results of different hypotheses. The first one, if there's all intercepts constrained, and here is the hypothesis testing. Now, null hypotheses are they're equal. The p-value is 0.034, so we reject the null that the intercepts are equal. Unfortunate for us because we would like to see that we accept this null hypothesis in order to claim scalar invariance and move forward. But the p-value is borderline, so there's a hope that this can be done with a partial scalar invariance. Indeed, for the safety intercepts, if the p-value is 0.276, non-significant for mindfulness. So mindfulness has turned out to be a great construct. All of the items meet metric invariance. If intercepts meet the scalar invariance, very good. Absorptive is a problem because it has 0.034, so absorptive doesn't have the right hypothesis outcome. So we want to test for each one of them. Those tests are played at the bottom here. You can see here. We do all of the 5 items. And you can see by looking at it, the most critical one is 38 with 0.001. 0.39 is close enough to 0.008. So 2 of the 5 items for which we had relaxed the intercepts, they don't meet the property, but 3 of them seem to be okay. Are we good? Any question at this point?
Yeah, sorry, David, it's Adrian. So I'm just trying to processing this as you're talking, so I may not be as fast as you are. But so there are 6 items on absorptive capacity, and one of them you had was fixed. So how do you make sure that that 6th one is not a problem? Oh, did anybody hear what I said?
Yeah, I heard you, Adrian.
Adrian, I did hear you. I did hear
Okay.
you. And what I said is that to answer your question, I need to go to my next one. You anticipated my question very well. So I need this, and I need this. Let's go back to this. So we have done this testing now. We tested for invariance of intercept. Now we're going to do this piece of it, and we'll answer the question that Adrian asked. We constrain all the invariant intercepts and loading. Earlier we only did the loading. Now we're going to constrain both the intercepts and the loading. And I'm going to do the following. Release the fixed loading, meaning the loading we had fixed earlier to that fixed value from a metric invariant. I'm going to make it free. But I'm going to constrain all the invariant loading from the metric invariant. I'm going to release the fixed intercept. The intercept which we had fixed to be equal, I'm going to release that now and test if that is invariant or not. And I'm going to leave the mean and invariance the same as before, fix the 0 in the reference group, and fix the unity in the reference group only. So the question Adrian asked is exactly what we're going to address next, and that is this one. Are we good to proceed?
Sure.
Yeah. Are people sleeping away and sitting on the line and enjoying themselves? Good. All right, let me go to the next step, which is this second run. What I'm going to do here now is, if you remember, for safety, this was the item Q48, which we had set the loading to be a fixed number. We had constrained it, intercept to be equal. I'm going to change that now. So the loading, if you notice here, is on A21, and in the other group, it is also set to be equal to A21. Typically, we should have released it, but we cannot because we need at least 2 items to identify the safety construct. I'll come to that in a minute. But its intercept we're going to make free. It's 2 I12 and the other one, oh, this is the same one. Maybe I changed it another one. So Q13.1, and the second one is Q13.2, and here is A11.2 and A11.1, and I want to show you the mindfulness item Q15. We have set it loading to a fixed value. Now I'm giving it a label, A51, in group 1. And in the second group is A52. So I'm testing it. The intercept is I22. And in the first group it is I21. So I'm going to test if this intercept is different or not. Finally, I believe the item in absorptive is Q35, which you have set to a fixed value. Again, A91 in group 1, and A92 in group 2, and the intercept I62 in group 2, and I61 in group 1. So I'm going to test the things I had constrained earlier to make sure that they are also invariant. The other intercepts are found to be equal. I'm going to make them equal now. So in mindfulness, if you remember, all items have equal intercepts. If I say Q17, you see all groups checked there, meaning the intercept is identical. Similarly for 16, identical. 15 to be left open because this we had constrained earlier, and 14 to be equal. We do that for each of the constructs so that we can circle back and check if those items which we had fixed before also have invariance. And you can see I have set the hypotheses for the managed models for each of the items. Q38, I check for that. Then mindfulness is Q15, this one here. Then absorptive Q35, which I set. And absorptive Q39, which has not met the intercept property before. So I'm going to test them again. Tell me if it's ready to proceed. Any questions?
Yeah, Jagdip, in the last analysis, you identified which of the factors, which of the items were variant.
Mm-hmm.
And in your slide, you say that what we're going to do is we're going to fix the invariant ones.
Yeah. Mm-hmm.
So in this example, how you fixed all of them. You didn't just fix the invariant ones.
No, I did. So the one we found to be invariant was 239 and 238 for the absorptive. So in this case, if you notice, the intercept is I-10-1 in group 1, and the log is.
Oh, I see. It's not. So what you did is the invariant ones you check the all groups.
Yes.
Okay.
Exactly.
Okay.
So we do step by step. Whatever we find to be invariant, we make them invariant.
Right.
And then we go to test the next step to see what is the remaining evidence. In this case, because some of them we had forced them to be equal, we want to go back and check. Any other questions?
Yeah, just, it's just really odd that, it's Adrian, that the safety items were really kind of flaky in metric variance testing, but in SCALAR they seem to be fine.
Yeah.
Just the opposite with absorptive.
Yeah, very odd, very odd. And I think the problem is that in order for us to work, the item we maintain to be invariant must satisfy both problems. So if they satisfy one but not the other, not useful. All right, so I'm going to run this to, it's already run actually, so I'm going to see the output, see what we find. As in all runs, we first want to make sure there are no problems in estimation, that's the case. Usually you should be looking at the estimates also and saying they're not odd. The kind of errors that is usually giveaway. If they are not of the same magnitude, it means your estimations have not been worked properly. In this case, it looks very nice. But I can tell you, to get us to make this work, we have to do many runs, and many times we made errors. So this is the usual place I go to check if the model is converged properly. Always look at model fits to make sure that the model fit is good. And you can see now the T-closes are getting better as we are really capitalizing on chance by fixing the things which are invariant. But our real interest is model comparison, and here are the results that we're interested in. Safety intercepts, I just checked that again, didn't see the same result, but not very useful because the items don't meet the property of metric invariance. So let's look at the remaining items from absorptive and mindfulness. Mindfulness first. Remember the item we had fixed the intercept to be equal. The p-value is 0.08, which means good item again. So mindfulness as a construct is a very strong construct. Every item even the one we had forced to be equal, meet the property of both metric and scalar. Right. Absorptive, Q39 is very clean. 35, the one we had forced to be equal, is actually the most offending. It is 0.021 and is causing the problem. Actually, once we released Q35, the Q38 became non-significant. Very common. You may see that earlier on in the analysis, Q38 was the problem, but no, it was only a reflection of the problem. The real problem was Q35, which we happened to, by random selection, constrain its intercept to be equal, not justified. So we could constrain 38 and 39, but not 35. So absorptive has partial invariance, but it does not meet full invariance condition because of 235, not 38 or. Are we good? Say yes, if we're good.
Yes, good.
Yes.
Good. All right.
Yes.
Yeah, okay, so now I'm going to close this because this part of the analysis is over. Let me go back to so what we did here, and then I finished the sheets. Now I'm going to come down to what I showed here. So here it says now constrain all the invariant loading and constrain all the invariant intercepts. So now we finished the analysis. We can go back and redo it. But now our goal is to constrain all of the invariants and constrain all of the intercepts which are invariant. Fix the mean of one of the groups to 0 and the variance to unity. And now we're going to test for the latent variance to be equal in the two groups. It says here equal to 1, but actually what we're going to be doing is testing if the variance is equal or not. I'll explain how it works. And what I'm going to do is pick up my next one, which is factor variance and variance. Here is that analysis. So in this analysis, you will see that all of the loading, there are no numbers anywhere in the intercepts or anywhere else. The ones which are constrained to be equal are the ones which were found to be invariant. So for mindfulness, for every item, I should find that they're equal, and I can check that. Let's say 14 parameters. It says I11, all groups are checked. Very good. And I want to make sure the loading is the same way. It says all groups is not checked, which means I must make sure that A42 is the same label in the two groups. I'm going to see producers and service providers, same way. So it's in fact the same thing as checking all groups. And I should find that Q35 here should not have either the loading or the intercept to be equal. Why? Because they have to be in pair. Although Q35 had invariant loading, I must release it now because it does not meet the scalar invariance property. And you can see that all groups is not checked. I62 in group 2 and I61 in group 1. The loading is A91, A91 in group 1 and A92 in group 2. So we just follow the basic idea to be consistent in the way we constrain and unconstrain. The key here is what I'm going to do with the variances. I want to test if the variance of this latent variable is equal in the two groups or not. I had said in the reference group, we're going to set to 0 and 1. So each one of them you can see is set to 0 and 1. In group 2, the mean is left open, but I have a label just for this reason, because I want to test if it's equal or not. So each of the latent constructs has a label, as you can see on the top, ABS-law2, and I want to test equality. And I do this by something here. So if I open this method model, it's testing for all variances Why do I do all variances, all intercepts, and all that? Because if you do individual comparisons, that's not a good practice. We should always begin with the omnibus test, putting all of them together. When that is rejected, then we do subsets. Never go to the individual right away. Subset meaning by individual construct, as you saw before. So in this case, we're beginning with all of them together. And notice what I do here. I say SWA2, that is the variance of absorptive capacity, equals to 1. Remember, in the reference group, we had set it equal to 1. So I'm going to test if this is also equal to 1. So that's what I'm doing. And we will notice I'll do that for safety, I'll do that for mindfulness, and I'll do that for absorptive, just in case my overall hypothesis is rejected. If the overall was not rejected, I would not look at the individual. Good. Can you proceed? Say yes.
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 All right. No questions. Okay. So I'm going to look at the output now. What the output looks like. Again, we begin by the notes of the model to make sure everything is okay. Estimates. Look at the center errors. All should be similar in range. They are. Let's look at model fits. And we can go down to this. So it's all looks good to me. And now I want to see model comparisons. We can see safety variance not equal, but for mindfulness and absorptive capacity, they are equal because the p-value is not in. So you can pretty much see that the safety construct is a problem, but mindfulness and absorptive capacity solid constructs can be used for understanding differences in groups. Everyone good? So now we are just basing our last analysis. I had said in the beginning, the whole purpose of doing all this stuff is to make inferences about latent means and latent slopes. This model, in which we have correlations among the three variables, is no use to us because there is no hypothesis of paths which we can test. So this is not the right way to think about it. So I'm going to change the model. But before I do that, I want to emphasize that up to this point, it's probably a good idea to leave these correlations in and not worry about the path. Although the model you're interested in is going to look like this. That's what your model is going to look like. I made a very simple model. Safety and mindfulness lead to absorptive capacity. There are two coefficients to be estimated. These are my structural coefficients. I want to know if these paths are different or not. Now I am ready to do it. So I need to now change those correlations. Replace two of them with a path. But the moment you do that, all things go haywire, and you need to readjust yourself a little bit. And I noted that in the PowerPoint, only by saying estimate structural model. This piece here has some more to it than what it seems. Let me explain. First, let's look at the dependent variable, the absorptive capacity. This is where the most of changes are. Because it's a dependent variable now, you can't set its variance to any value and so on. So what we have to do is we have to set one of its loading to a fixed value. I don't choose one. I choose a value, which in this case is 0.397, which is the exact value estimated in my last line, the scalar invariance line. So I pick up the value from there, and I use that value here. Notice the intercept is 4.015. How did I get it? This is exactly the intercept of 234 in that scalar invariance one. And I make it equal in the two groups, so all groups are checked. And this will make it a way to identify the absorptive constant. Are we good?
Yes.
Yes, we're good.
Good. Any questions? All right. There are no questions, so we understand that. Now, the other thing I did was the absorptive capacity. The intercept in group 1 is set to 0, as we expect in the reference group. In the second group, service provider, I give it a name, adds mean 2, to be estimated. Very interested. Is this mean different in the two groups or not? So I put it like that. Similarly, for safety, I have SS mean and S raw to be estimated in the second group. Similarly, for mindfulness, the MF mean and MF raw. Very interested to know if mindfulness will differ in the two groups or not. So that didn't require any change except giving a label to the mean because I'm interested in it now. All other stuff remains the same. Nothing else changed. The only change was here and the intercept for itself. Oh, one more thing. I added the other variance for the latent construct, which is to get your R squared. And the only hypothesis I want to test of great concern to me would be for slopes and means. Here is the managed models idea for slopes. I'm testing if the coefficients are equal or not in the two groups. You may say, so what happened to the means? Well, remember the mean of both constructs in the two groups, in the reference group is 0, whereas in the second group it is some value f mean. And I have to test if this mean is equal to 0 or not, which I will show you in a moment when I go to the output. So that's the output. When I run this, again, the overall model should be good. Estimates should be of similar standard errors. They are. Model comparison, model fit precisely. Model fit, you can see C close is 0.158, which is very reasonable. We can look at other fit indices like IFI and TLI and CFI, just make sure they're fine. Model comparison shows that the hypothesis of equal slopes is not rejected, is accepted. So the two slopes are equal in the two groups. So that's the latent slopes, they're identical. What about the means? The means happen to be in this part called scalar. That's where the means are. And you want to know means for the two groups, producers and service providers. You want to know it when the coefficients are set to equal. So I'm going to click on all coefficient models. And I'm going to go to the intercepts first. The first intercept shown is adds mean 2. That's for the service provider. The estimate mean value is 0.407. So it's saying that in the service sample, the absorptive capacity had a mean of 0.407, whereas in the producer group, the mean was 0. So you're always comparing with respect to the reference group. Well, it is significant or not. This hypothesis testing is always done traditionally, whether 0.407 is equal to 0 or not. So this p-value is highly significant. So you reject the null hypothesis that the mean is equal to 0, which means that the service group mean or absorptive capacity is significantly different from the mean value of the producer. And this goes back to my beginning. I said in many studies, slopes might be identical, and you may conclude that there are no differences. Wrong. There could be differences in latent mean, and this is the result from it. This is a very powerful result because this is not a mean difference on individual items. It's not a mean difference on target, like ANOVA would do, is the mean difference after controlling for measurement error. And if you had common method and you had other ways of controlling biases, this would be even more vigorous test of the latent mean. You may say, what happened to the other two means? Well, here are the means for mindfulness and safety. And as you can see, the mindfulness has a p-value of 0.062. So the mean for mindfulness does not differ between them. Safety mean does differ by a huge amount, 0.928. Telescope is far more positive than the producer group on safety, and it is significant at a very high level. The only problem is safety as a construct cannot be trusted. So this particular test is not very credible because the scalar invariance and the metric invariance for this construct is not different. That, in a nutshell, concludes my presentation. And you should have all of these famous files to play with and the data files to work with. And I'm happy to answer the questions now.
Thank you for going through all of that, Jagdip. We really appreciate it.
Jagdip, I've got a question. In this particular case, you had a very, very simple model. And for the last step, where you're estimating the structural model, if you have 7 constructs, it doesn't matter how you connect them causally as your theory would lay out?
That's right.
Okay.
I think it doesn't get more complicated with more constructs. The only requirement is you must have good measurement. If you have that, things work out very clean.
Yeah, this is very impressive. Very extensive.
Yes, it is.
Yeah.
It is. But I just want to emphasize, that when you're doing hypothesis testing, if you miss out means, you will be missing out differences that are quite relevant. Can you imagine in a real setting, you say performance levels may differ in the 2 groups, and you have missed it out completely because you never estimated it in mean. Okay, any other questions from those who have had the courage to stay back and listen? Do I have no questions? Can we close it at this time? Give me a yes or no.
I'd say yes.
I see.
I think this has been good. Yeah.
All right. Well, thank you. I did want to hear some yeses, and I hope that I'm not just talking to Adrian. So with that, I close this session, and thanks for taking the time to be with us. I'm sure that a lot of things will come up when you start using it. Just wait for the videos from Aaron, work through it yourself, and then question and pick it up as a residency.
Enjoy your wine.
I surely will. And you all have a good evening.
Thank you all.
Thank you.
Bye.
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 Good night.
Bye.
Thank you. Yeah, I have a very nice one, but I just didn't bring it.